Hello everyone, welcome back to another video. So in the last video we went through what a solar charge controller is, and in this video we're going to be trying to balance my supply current and my load current. So we was using my battery and solar 5-volt solar panel to charge the battery. Now we determined that using the Raspberry Pi as well as the function generator with its boost converter, we figured out that that would be using 280 milliamps of current. So what I figured I would do is I would put a switch between the Raspberry Pi function generator and the solar charge controller. So a switch right here, so that way I would just be able to have one of them on at a time. So I could either turn on the function generator or I could turn on the Raspberry Pi. And so that meant that the function generator was only using 100 milliamps and the Raspberry Pi was using 180. So the maximum amount of load current that I would be getting from my entire circuit would be 180 milliamps. So I can completely remove the function generator and just work on the basis of the fact that my max current draw from the battery is going to be 180 milliamps. So what we did look at was how much current this solar panel could produce on a cloudy day, which was 40 milliamps. Now the reason why I did cloudy day is because I'm in the UK and obviously, you know, we don't get that much sun. So what I want is that during the daytime, my current coming from the battery to my Raspberry Pi, 180 milliamps, is going to match what I'm getting from the panel into the battery. So what we figured we would do is, instead of just having the one panel, we would then add some more panels. So that's what I did. I ordered 4 more 5-volt panels. And so if we stick these panels in parallel, not series obviously, if we stick them in parallel, so we've got 5 panels, if they each produce 40 milliamps of current, 40, 80, 120, 160, 200, and so we should be getting 200 milliamps of current. So what I need to do now is I just need to connect each one of these panels up into parallel, connect them all together, and so we should have 5 volts from all of them, but each one producing 40 milliamps. And so at the end here, coming into our charge controller, we should be getting 200 milliamps of current. Okay, so the first thing I want to do with all the solar panels is I want to get them to this stage whereby I've removed the circuitry that comes with them, which is just like a little diode with some silicon stuff. Cut off this wire as well, and then I want to solder in some points into here. And then once I've prepared each solar panel, so you can see I've got to do it for these 4, then I can connect them up in parallel. And so I'll show you how to do that. So I'll show you how to do that then once we've cleaned these up, basically removed this stuff, because we literally just want just the panel, we don't want any of this stuff. So obviously got to take off all of this wrapper. Don't know if you guys enjoy this. The sun's not, it's actually not coming off as easy as I thought it would. Alright, so now with this, it's actually quite difficult to get this off. Well, that one kind of just, okay. It's a bit easier, actually. Oh, no way. So that just came off super easy. So this quality one, I mean, it's better. Definitely, that was actually much easier to deal with. So you can see there's a diode there and the wires. So hopefully all of them are like that. So that's just there. We're going to just solder wires into there afterwards. That's one done. No way they're all just coming off that easily. Look at that. So the plan is to get all of these basically with a wire attached to them. So I can do it here or I can do it here. I'm going to go and do it at the top ones here, just like I've done this as well. So positive, negative. We're going to do red, positive, green, negative. Solder them all on and then we'll connect them all up in parallel. Alright, there we go. So here's our original one, and then here's all of the ones that we've soldered on. So now we simply just need to wire them all up in parallel and we're done. It's actually super simple, to be honest with you. Okay, so let's get into how we wire these up, right? There's 2 ways. We've got series and parallel. Series is just basic, so you've got the negative and the positive, right? So you basically just want to make sure that you have like the negative end here, and then you just connect, you know, this to that like that. Same again, connect these 2 together. Same again, connect these 2 together. And lastly, connect these 2 together, and now you've got your positive end here, your negative end here, as you can see, and you've got a 25-volt solar panel. So it's I mean, that's basically what these are. These are just cells, and they're just connected in series. And so by doing this, you're just going, look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and you get it, right? So you're just connecting little individual cells in series, and then now since we've got 2, 4, 10 cell panel, we're just connecting those 5 in series. We obviously don't want 25 volts. I just want 5 volts, and I want the extra amperage. So instead of doing this, what we're going to do is, what we want to connect all of the negatives together, right? And so when I say we want them together, it's going to be tricky to do it like this as I've done, but I'll just explain it for now, and then you'll see. And then all the positives together, basically. So my wires aren't long enough. But what I want is, I have my 2 terminal pins here. I just want every single positive wire going into one, and every negative going into the other. And then I'll have a positive and negative there. But all the positives have to be connected. None of the positives touching the negatives, and all the negatives connected. None of them touching the positives. So I just need to extend all of these wires, which I'll do now. I'll just solder on an extension. I mean, I could just retake these off and just put longer wires on, which I might just end up doing. I didn't really think this through in terms of adding my wires onto it. So let me do that, and then you'll see what I mean at the end. All right, so what I've done is I've just connected 5 negative wires, 5 positive wires into each terminal, and then I'm just going to connect them to the panels. And then, yeah, should be nice. Should be easy, to be honest with you. All right, here we go. So it looks terrible, but I'm trying to take this approach of, you know, done is better than perfect. So I just kind of soldered on all of the connections there. I could have used like these jumper pins again, but I didn't have any smaller ones left. So I didn't have a lot, so I just went with these. But anyways, it's fine. So I've tested just using my continuity meter. I've just tested touching here and touching the last pin there, to make sure they're all connected to the right place, and they all are. So you can see all the greens are connected to here, all the reds, the positives, are all connected to here. So I should be able to test the voltage at these terminals here, and we should get a solid, well, I don't have a light on right now, but we should get the same 5 volts ish, you know, maybe 2.5 to 5 volts, but we should be getting a lot more current when we connect this panel into our circuit. Okay, so here we go. We've got our 5 solar panels going into these terminals here, and then we've got them coming out from there, the black and white, going into the solar charge controller, and you can see the charge controller is on because we've got our battery connected. So there is no charge LED that's currently being shown there. This LED should be highlighted red, should be turned on once it's charging. So let's check our voltage to see the reason why it isn't charged. I can't really get a decent, you guys are gonna have to trust me. We've got 3.3 volts right now. All right, so I have this LED ring light. If I put it over, you can see there that it's the charging LED is turned on. If we check the voltage now, we get 4.1. Okay, interesting, because it shouldn't be charging except with 4.5 to 6 volts. That's the input voltage that it needs, but it's accepted it with 4.1. So at least we know my circuit is working. Now let me connect these onto the window, and then being it's a cloudy day, hopefully we should get a decent voltage. Yeah, let's do that. So let's first see if we can get 5 volts. Once I've confirmed that I can get 5 volts from this setup, then I need to connect the multimeter in a way that I can read the current coming from the solar panels. Hot today, but it's also super cloudy, so let's see what kind of voltage we can get. All right, so I've taped all my panels to the window. They look horrible, I get it, but again, you know, just done is better than perfect, right? The purpose of this is just to see if I can get it working, right? So let's do that. So I'm just gonna check the voltage here now. Hopefully we've got a solid 5 volts, and then we'll check the current. And would you look at this? So checking the voltage, and it's 5.4 volts. That is amazing. That is so good. So it's got a nice solid 5 volts. Thankfully the sun's come out a bit, which is nice. So a nice solid 5.4 volts. So that's good. We don't have 25 volts. We didn't connect them in series. So now let's check the current. So I've connected in the solar charger, and then I've just stuck the multimeter between the solar charger and the solar panels. And we can see here it's fluctuating a fair bit. I mean, just before I press record, it was at 175. Now the current is dropping. 151, climbing back up again. Guessing it's got something to do with the clouds. Now, I was expecting it to show 200, but you know, this wouldn't cover the Raspberry Pi, because the Raspberry Pi needs at least 180 milliamps, and we're only getting 165. However, I've obviously worked out the concept. There may be some kinks in terms of, like, you know, for example, I've pushed the solar panels into the windowsill, so maybe that's causing some problems. I can work that out, and you know, we could always add another panel, for example, and definitely get this to the 180. But I think I've proved to myself and hopefully shown you guys that, you know, this is how we can get more current into our whole circuit. You know, whereby I had one panel that was producing 5 milliamps when I was just using my LED light, this one here. When I was just using that. Then when I moved it over to the window, we was getting 40 milliamps, and then now if I stick them in parallel, now we're getting 100. Look, 174. So yeah, I think one more panel and you'd be at 200, and then that would be good. You know, you would be able to run a Raspberry Pi literally off the battery. You could charge the battery during the day, and you could run the Raspberry Pi all night. I think that's that about wraps this up. You know, I'm gonna go a lot deeper now into solar charge controllers. I'm gonna try and figure out, you know, all the circuitry behind this and how this works. So I think that's enough of the practical side. I'm going to be going now more in depth into the components and the circuit side. So if you're into that kind of thing, subscribe, and yeah, I'll see you guys around. Thanks for watching.